Hey, Algebra 1, Lesson 103 has us rationalize a denominator, meaning if there's a square root or a radical sign of any kind down there, we want to get rid of it, or else we won't be able to use it. It's an irrational number. So we got to rationalize the denominator. I'll share this file I'm about to go through here to start with you on Classroom. It's kind of it's a shockwave file, so I don't know if that's going to share or not. In case it doesn't, I'll just talk through. This is the initial information for the lesson today. It says to simplify fractions with radicals, we may have to rationalize the denominator, meaning we write the fraction so there's no radicals in the denominator. Say you have 1 over square root of 3, you can actually do something with that to make it so that there is no radical in the bottom. Multiply the numerator and denominator by the same factor, right, because you're allowed to do that. That makes the denominator a perfect square, meaning multiply the bottom by itself, top and bottom by square root of 3, leaving you with square root of 3 over square root of 9. We know square root of 9, being a perfect square, turns into a rational number, 3, at the bottom. Now we have square root of 3 in the numerator, which is okay, and no longer in the denominator. A square root expression is in simplest form when no radicals, have perfect squares, and there are no radicals in the denominator. We're there.
Simplify the square root of 11 divided by the square root of 5. Simplifying expressions with radicals may involve rationalizing the denominator. To rationalize the denominator, multiply the numerator and the denominator by a factor that makes the denominator a perfect square. Five times 5 is equal to 25. The square root of 25 is 5. Multiply the numerator and denominator by the square root of 5. Use the product property of square roots. The square root of 11 times 5 is equal to the square root of 55. The square root of 5 times 5 is equal to the square root of 25. The square root of 25 is equal to 5. The denominator has no square roots remaining, and the numerator cannot be simplified. The expression is in simplest form. Simplify the square root of 15 divided by the square root of 6 by rationalizing the denominator.
So the denominator gets multiplied, and the numerator, by that quantity in the denominator. And when you square, or I should say you multiply square root of 6 by the square root of 6, you'll end up with just 6. So they kind of make it easy for us. They only have 1 with that denominator. Oh.
Make the denominator a perfect square.
I would have thought we did not multiply the denominator and the numerator by square root of 6, which would make it square root of 36, wouldn't it? Not sure about that one. Let's see what they say.
Multiply the numerator and denominator by the square root of 6. Use the product property of square roots. Multiply. The square root of 36 is equal to 6. Simplify the numerator. The square root of 9 is equal to 3. Divide out.
Didn't see that coming. Okay, so we got to be ready for that. If we square the bottom by the square root of 3, you end up with 3. You end up in the top with 6. Well, I know it's got to be this one because the other ones are not rationalized. All right, that one was easier. Ooh. This is hard to do without being able to write. gotta be the top one then. Let's do some of these here. I'll make sure that the fraction bar is obvious here. So in this first one, the rule is pull out your perfect squares if you have any first. Okay? And since the top, right, we have the perfect square of 25 times 2, and we can pull out all these y squares. So like y squared times y squared, these are all perfect squares. Meanwhile, on the bottom, we've got 4 as a perfect square, and then there's 7, a couple of y squares, and then a y. What do I do with this? Okay, so the 5 comes out, giving me 10, and I'll put the 2 underneath the radical for now. Then I've also got a 1, 2, 3 y's that I can pull out. So you basically divide that exponent by 2. The 6 becomes 3 on the outside. That's all I have left on the inside. What's on the bottom? I can pull out 2. I know 7 stays inside. 1, 2 y's. And there's a y left over underneath. Now, we rationalize by multiplying top and bottom by square root of 7y, so that it rationalizes my denominator. Now I've got 2y squared 7y on the bottom. Still have my 10y cubed square root of 14y, right? Simplify. This is really y cubed, and this is 10y cubed, so I can remove this, and I can divide 10 and 14 each by 2. Giving me 5 square root of 14y over a rational 7. Okay? That's how I solved that one. So pull out your perfect squares first. Now let's try this one. I did this because it teaches us conjugate of an irrational number, meaning the conjugate here for the bottom, we have a binomial going on. So what we're actually going to do is multiply by what's called the conjugate, which is just take this, change the sign, see what happens. Instead of plus 2, we minus 2. Got to do the same on top and bottom for it to be fair. So what happens? Square root of 7 times square root of 7 is 7. Let's see, outside, so 2 square root of 7. Inside, see what happens there. Last. Extend my fraction bar. Meanwhile, the top is pretty simple. Okay, combine like terms here removes these ugly things. 7 minus 4 is 3 on the bottom. 6 square root of 7 minus 12 on the top. And it looks like we can even simplify further, right? Either by going like this, or what I might like better so that we don't make any mistakes. Let's factor the top, taking 3 out. Then we have 2 square root of 7 minus 4. You see what I'm doing there? I pulled out 3 from both of these. And then I've still got the 3 on the bottom. Beautiful. That looks better. I like that better. Leaving me with, oops, this should say 7. 2 square root of 7 minus 4. I bet you're just hankering to try this yourself. By the way, that was an example of what they're doing on example 4, page 693. Why don't you give letter B a try, letter C, and letter D? A little bit of a challenge there. Try those 3. I'll post answers tomorrow.